So my talk tonight is going to be a bit more technical, so in that way perhaps not quite as provocative, but that was a perfect segue from Michelle into this topic area. The disruptors that he talked about, right, in OTT leading to this digitization of advertising and this direct relationship with the video consumer. Every one of the companies he talked about and those projects and initiatives he talked about uses the technology approaches I'm going to talk about tonight. For example, the MLB Advanced Media Services, HBO, is sending a lot of content to them right now. And we're involved in that. Netflix, Show Me, the CBS case, right, and Dish as well. The reason I wanted to do this talk tonight was to explain from the vantage point of the technology what I see as being some of the key enablers in getting done from a technical standpoint what Michelle was talking about. Aspera, albeit very much behind the scenes, has an interesting vantage point because we provide digital data transfer, high performance, focused on big data and IP networks. What that means is we've ended up with our primary application area being in the middle of these video file transfer exchanges going on in the plumbing of the companies that are doing these things. And the other thing that Michelle's talk helped me realize, which frankly I thought was brilliant, was that the very disruption that they're achieving, right, is coupled all the way back to the technology decisions they're taking. And by no means is the high-speed transport portion that we do, the be-all and end-all of what makes them what they are. But it is part of a choice of workflow approach to file-based workflows, cloud-based approaches, and deep use of internet content exchange that I think is enabling them to be what they are. And so as I go through the use cases I'm going to talk about tonight, I think they will help you see kind of the fabric of what these companies are doing to help enable those disruptive services. Last thing I would say about this is I wanted to make this educational in regard to some of the key technology points. So of course I'm going to give a little foundation in the transport problem, which is especially unique to how Aspera solves it, but that is merely to give you the foundation. So long way of saying no commercials here. Every case I'm talking about though does use our technology as the transfer fabric. So with that, let me get into it and let's see what you find. So firstly, I want to talk about a summation of the drivers for the technology trends, okay? And those are going to be utterly obvious to you after the last hour that we've just spent. The particular drivers that call for high performance, high capacity, digital video file-based movement over internet. That's what this all is all about in the interchange, right? Also emanate from these use cases, this situation that Michelle talked about. I'm also going to talk about cloud techniques, right? Because that's also part of the disruption, right? And I'll just start with Netflix, right? Top of the list. All of the video that is ingested to Netflix daily goes to the Amazon S3 cloud, happens to upload with our software. Netflix drove Aspera to develop a direct-to-cloud transfer capability. And the interchange or between this technology movement of OTT and what has happened with digital media in the cloud is just directly coupled. Right? Then I want to share with you a little bit about the foundations of our software, because that helps you to understand the use cases that I want to go through, which have to do with the whole, if you want to call it, supply chain that goes behind the OTT disruption that Michelle talked about. Ingest, all the transformation that goes on to prepare the OTT formats, both the main content and the advertising, right? And then the distribution delivery. And this last year has been particularly interesting on delivery because two new things happened. The CDNs got into this, so I'm sure many of you are aware of Akamai and their competitors. Akamai built a global storage platform using cloud-based storage techniques. Our software has been integrated into it for the primary purpose of being able to extend this OTT chain that pumps so much streaming video content into the Akamai network for the purpose of distribution in OTT. That never would have happened if all of these trends in the industry weren't going on, right? The other thing I want to mention was also the influence of live, right? And Tony said something that, or excuse me, not Tony, but Michelle said something that I want to augment a little bit, which is he said that live is really sort of the last bastion of traditional broadcast because it constitutes appointment TV. Even it is changing. Near live second screen experiences, and the single big, most pivotal technical advancement for us in the last 6 months has been fast stream due to being involved in the World Cup, due to second screen live or near live experiences that had to happen, where the live source is in Brazil, the cloud transcoding is in Europe, and the streaming content had to come, near live with the match experience. All that was done with the same techniques for the very first time over commodity internet, to cloud-based transcoding using Elemental, delivered with our software and pumped out through Akamai, right? So this is what Michelle was talking about, right? So obviously I'm excited about it like he is, and I think it's appropriate in a SMPTE venue to show that kind of engineering enthusiasm. So for the next 45 minutes, bear with me, I want to tell you a little bit about these things, okay? So first, why is Aspera in the middle of this in the role of transport? We, as engineers, I'm one of two founders of the company, started 11 years ago. At that time, the internet and content were starting to come together. We happen to have a lot of interest and technical background in what you would think of as application level networking. That is, what do you do over IP for applications that allow for, in this case, transport of content? Data sizes were getting bigger. You could tell that video was going to be a major force, but this was 2004, right? So we're talking about before this internet OTT era broke, right? It actually started, in my opinion, with iTunes, and I remember the first iTunes deployment in 2006, right? At that time, all that was clear was there was this growth of content, growth of internet, and increasing footprint distance, right? And then this desire to get predictability, speed, and efficiency over it, right? And there's some specific technical problems behind that. The reason I want to pause on this is saying this is a very big deal is because this isn't about fast file transfer. It's about the fact that the internet made possible the content movement that is at the core of this new supply chain. But without a technology innovation, there was no way to realize the speed and predictability over internet conditions that are necessary for it. Right? That happens to be the purpose of our company. That's what we do, innovate technology that solves those problems. And then around this, of course, we've had these things going on. The growth and the size and the volume of the content. We've had proliferation of formats. We've had this insatiable appetite of audiences to get more media, growing audience expectations, and then everything that Michelle talked about in terms of shifts in the ecosystem, right? Which brings me to what I want to focus on, which is what does that really mean in terms of the technical problem behind this, right? Well, first is the data explosion. Imagine how many bytes of video are created, stored, and transferred every day. Right? I don't know the actual numbers, but I do know the typical Aspera customer moves several terabytes a week. Typical in media, several terabytes a week, right? The bigger ones, 100, 200, 500 terabytes a month, right? It's enormous, right? That's just what they move, not what they generate or store, right? The other is this shift, this file tape shift, right? CBS, I will, since he quoted the CBS, I will tell you this situation came from CBS. They told me one day in a meeting, last year it was 20/80. 20 tape, 80 digital transfer, or excuse me, the other way. It was 20% digital transfer, 80% tape. They said this year it flipped. it was 80% digital transfer, 20% tape, and that was a couple years ago, right? Very traditional broadcaster, in the span of 1 year, a complete transformation in how they were doing their workflows and also how they reach their audiences, again, because of this OTT revolution. And they commented that Netflix was the initial major driver of that, right? And then, of course, the media itself. And I want to talk about one thing that isn't often said. It's not only giant files, right? A 4K movie happens to be between 1 and 4 terabytes, depending on exactly the length and the specifics of it, right? But it's also large sets of small files, right? It's also large blobs, right? When you think about stream content, I mean, maybe there isn't a start and a finish, it's just a big blob, right? So the content is large, the way it comes and goes is variable, right? And dealing with all of these other factors, it must be agnostic to those differences in the data, right? Or the video in this case. The next thing is IP, right? So we all know IP is everywhere. We all know that ad hoc mobile networks are the latest trend, in the IP growth. The bandwidth range now, I think, 7 to 8 orders of magnitude and the bandwidth that we actually work with, right? Because if you think about your personal Wi-Fi connection or 3 or 4G mobile connection, all the way up to easily 10 gig, and now we've got some of the more advanced companies getting into 40 gigabit networks, right? You're talking about 5 to 8 orders of magnitude, right, of difference in bits per second. So tiny to huge capacities. And the consumers also are dealing in these variations. I was at Facebook just a couple of months ago, and the group there that I was meeting with told me that their biggest concern is not at all the consumer or fiber. It's the mobile user, because almost all the video they care about actually is personal mobile generated, right? The youth revolution and all of their video innovation is actually focused on the mobile situation. A little bit different than Google Fiber, for example. And then the other piece about the IP networks is distance, right? And distance isn't really the root of what's interesting. It's the variation in the network quality that comes from that, right? And in IP, most of you probably are familiar with this. Packets get forwarded, right? And they forward best case at the speed of light. Of course, they don't actually, because they go through router memory, and there's buffering along the way, and there's something called the round trip time, which is the time it takes on average for packets to traverse the internet route and get acknowledged back. There's also a probability of drop, loss, right? And the loss drop comes from a few factors. It comes from the media itself, right? So if you're on a wireless media, the drop rates come from actual channel loss. And if you think a layer above that, they also come from congestion, oversubscription, for example, because routers, after all, are just another form of computer with finite memory, right? And routers implement discard policies if they're too full, right? So these two factors combine, right, and cause a particular response function in traditional transport, right, which has created an interesting situation of underutilization in a lot of cases. The bigger issue to everything that's happened 10 years later is that on its own, traditional technology, given these network conditions, cannot deliver the predictability that this kind of supply chain needs, right? And that would open the problem space, right? And then as we've gone further, right, we've entered a time where not only is global consumption the norm, global production is the norm, and we've moved from just getting point video ultimately to the consumer to something that's immediate turnaround to live and near live and live experiences, right? And that goes across this entire OTT segment. What I find the most interesting is the time to market. Of course, you have the ultimate live experience, but even when you think about online streamed content, most of that is being prepared and produced and put online, immediately in the course of many of these events. And something like the Olympics is constant uploads to go to YouTube and various competitors like that. And then lastly is cloud computing and the role that it plays. And I mentioned this, I'm going to talk about it more as we get to further slides. All of the disruptors that Michelle talked about, every company example he cited, has some element of use of public cloud infrastructure if not, or on-premise cloud style build out of compute, storage, and bandwidth, just to get economies of scale and elasticity in the models. And I'll talk very specifically about the leaders, and the most obvious is Netflix, in addition to MLB's case, where the advanced media services all gets powered on Amazon's cloud. So the transport problem, right? So I want to spend about 5 minutes describing this and explaining it, because it underpins why, all this file exchange it can happen in the first place at the speeds that these workflows call for, with the capacities they call for, and why this wasn't possible 10 years ago, and then also what this means in the cloud, right? So the first thing to notice is the shape of this plot, right? The plot is high in the back and low in the front. This is network round trip time. This is packet loss, right? What you're seeing plotted is the achievable throughput using traditional reliable transport with the classic TCP protocol, which underpins every type of reliable data transfer that we do over the internet. HTTP, for example, FTP, SFTP, rsync, Windows copies, NFS copies, etc. The reason we pause to look at this is because you can see that both factors together have not only an inverse, but it's inverse with the square root of the loss impact on the achievable throughput, right? So the main point about this is that you can't do anything to fix this. You can't change it, meaning there's no way that you can add bandwidth and get better effective throughput as you go farther distances. The other thing it tells you is that even if you improve upon this curve, you still can't get absolute predictability, right? And think to this OTT world, where instead of using satellite live feeds, you expect to transfer digital content in file form from A to B to C in some predictable time, right? And how far you have to go varies, from local area all the way out to around the globe. You cannot operate a system like that this way, right? That's the key takeaway. And I will come back to these slides I skipped over in just a minute. The whole premise, right, of what we do at Aspera, and what I think underpins the possibilities around the interchange of the content, is to eliminate this bottleneck in the transport software at an application layer, so that the media can move with predictability, independent of distance, and high efficiency, right? And there's lots of things to say about Aspera technology that make this possible, right? But it's worth pausing to understand that this is true. It works, and it opens up many possibilities in these workflows that then in turn power the OTT supply chain that Michelle was talking about, right? And specifically, the achievable throughput does not degrade with round trip time and packet loss. The rate of transfer adapts according to other traffic's needs. And also, because it's built as application software, right? This goes right back into the business problem. You can then exploit this to control speed, to realize certain transfer times, delivery times. You can also exploit it to ensure security, right? Reliability of the transport, so this is fully reliable. And you also have the ability to scale it up with a lot of concurrent jobs going, right? So this is the sum total of what I want you to understand about this platform. It breaks that bottleneck and makes transfer, right, times proportional to available bandwidth. No longer falling off with distance, right? And what that then allows us to do is take all of this digitization, which digitization turns into bytes that make the files and the content, and say we can build a supply chain now that allows us to transfer in predictable times regardless of how far we go, and also allows us to use our bandwidth, right, choose how much bandwidth we use in order to achieve the SLAs that we want, right? And this idea of distance independent or network independent efficiency is a really big deal to the use cases I'm going to talk about, okay? Now I want to say one more thing about the root problem, which is when cloud came along, this idea of a cloud, which means a lot of things. In public clouds, it means that there is
shared infrastructure for compute and storage, like Amazon's cloud, right, and bandwidth. If it's inside of a company, it means usually some centralization of those resources to get, an economy of scale, right? When that happens, often the data source is far away from cloud storage. And so take two cases in Michelle's talk, Netflix and Amazon Prime. Both of these services launched with the idea they were going to exploit Amazon's cloud environment, right? They use primarily Amazon's cloud for transcoding, right? Netflix's idea was we are going to transcode at extreme scale, very low cost. And Amazon Prime was right behind them, right? Copying these techniques in order to utilize this hugely elastic compute farm of the cloud as needed for transcoding, and also to use the bandwidth, if you will, for distribution, at least out to CDNs, right? So with that in mind, the video starts somewhere out here at the content provider. Remember Michelle's chain? So to get that video from there to where they need to transcode is a long distance transport problem, right? You've got a wide area network. This problem came up all over again because the APIs exposed by cloud storage, starting with Amazon and now every platform that's modeled after them, Azure, Google Cloud, Akamai Net Storage, SoftLayer Swift, you name it. All of them, their native interface is HTTP based. So you would be left with this TCP transport problem all over again for moving video in and out of these environments, and it's a non-starter. Example, when we started serving Netflix, they had all of their servers on premise in a data center, right? And then after the Aspera upload from the content provider to the data center, they would use the HTTP post APIs to post the content into Amazon S3, right? So what happens? The big files, which are slow, the post itself is unreliable, and then in a moment you'll see that in addition, because of the nature of cloud storage, those large objects need to be divided into lots of pieces, right? So they came to us and said, Aspera, we cannot do this two-step process. We need you to go directly to the cloud storage, right? And the reason I'm mentioning this, right, this is what they were doing from data center to cloud. Amazon Prime doing exactly the same thing, right? They were receiving content into Aspera servers here, using this native API over HTTP, and they're, in this case, not even so far over the WAN, to divide the files up into pieces and post them in, right? So that created sort of this second generation of problem, and those companies said to us, we need you to go from the content source all the way to the cloud storage, right? This led to the innovation of a new piece of technology that I would say after the core transport has been one of the single biggest game changers, if you will, disruptors in technology for achieving these OTT platforms, right? And Google Fiber and YouTube also run this today, same way, right? And what it allows them to do is to get content from provider anywhere in the world in single transfer, upload operation, so single stream over the network at available bandwidth capacity, regardless of distance, direct into the cloud storage. And that cloud storage type, object storage, is very cheap relative to gigabyte, right? And that's what these guys have done to sort of change the nature of storage for these huge media farms, where they do transcoding and they do major digital lockers, and in turn make these highly competitive OTT services, right? The cost per gigabyte is much less than traditional enterprise block storage. I won't go into all the details of this, but what we had to do in order to engineer this is build a whole layer, a virtual file system layer in our software, application layer software, focused on wide area transport that would allow us to do I/O against the storage, right, without disrupting speed, encryption, the resume properties, and the rate control, right? So I say all this so you can sort of understand where everybody is positioned to go as a result of this. And in this last year, these two companies, Akamai and Limelight, built their own variations of this. So Akamai launched a version of our software embedded in net storage last fall at their Edge conference, and it serves exactly the same purpose to open up Akamai's CDN, right? So it actually looks like this when you see it in the large. There's 90-some thousand Akamai servers around the world with this, with our software running on them. It allows this to be the next hop, if you will, in these distribution chains for the over OTT services. Because everything's still flowing in its file form. It comes in at high speed. It lands directly on this scale-out storage, right, that's very cheap and lets them, go bigger, if you will, for less cost and serve these sort of massive streaming audiences. And those of you who've been watching the press know that Akamai has been growing not only very fast, I mean, they had a record-breaking streaming audiences during the World Cup this summer, even bigger than during the Olympics. So start to see how this stuff feeds together, right? And then the latest wave in this that I want to talk about has to do with these fleets, right? I would call them fleets of host computers running the software that does this auto-scaling, auto-growing and shrinking with load, right? And there's some specific technology we've built that enables this. What is most important to this OTT message is the fact that these companies, in the beginning, the last 2 to 4 years, as they've gotten into this, have built their own scaling mechanisms so that they can provision new virtual machines and configure them as they go. After a while, that only goes so far, right? And this technique allows for a built-in technology to do scaling against client load, start and stop new machines as they're no longer needed or as newer needed, allow for a certain number to be running for burst capacity, and exploit this elastic style of having bandwidth and transfer throughput, if you will, in and out, and then also that can be coupled with storage needs as well. So you can, again, start to see where this kind of thing goes, right? So this is a lot about the Aspera technology, but I think it'll help you understand as we get into these use cases. And then this stacks up into a suite of software, right, that allows for doing these things with VASP, our core transport is at the core, and then this direct integration with all these guys, and these guys are the ones that are building these services that we talked about, right? And then the management automation and end user interfaces that make it easy to do these things. Okay, so with that, where are we out of time? What are we, 32, okay, about half. So for the next sort of section of this, I want to talk about specific use cases among these companies and how they're exploiting these patterns in technology in order to create the services we've been talking about. Typically, the use cases break into ingest, where we're talking about getting content from its original source into some processing area, right, for transcoding, QC, preparation for distribution, and in these web OTT services, the number one operation is typically transcoding. Moving into the servicing sort of real-time transcoding pipelines, for example, and then finally moving into distribution of the content itself, right? And all of these things involve the movement of bytes. What's interesting is then how this gets exploited both at the transfer level as well as at the workflow level. So let's start with a really simple use case, and then we'll get into something more interesting. So a typical situation. Customer runs some kind of transcoding service on premise or nowadays in a cloud environment, right? And there are several companies that offer these types of transcoding farms on the cloud. Elemental Live, Encoding.com, Telestream, for example, et cetera, and some companies build their own, right? Tools like FFmpeg, for example. Out here, we have some myriad of sources of content, right? If it's news, the news itself may be actually captured on camera and uploaded in file form. If it's coming out of episodic television, it may be recorded file that is uploaded directly into an Aspera server. Common application might be very simple with a Dropbox with some metadata, drag and drop the content into a web page and upload it directly to the server. And then as that's getting uploaded, transcoding takes place, right? And a subsequent downstream recipient of that content is either notified, download the content, or receives it pushed directly, right? Very straightforward. Well, a couple of the things we've done here is first shifted, right, the transcoding out to the cloud so we can take advantage of a lot of compute. We've shifted the ingest bandwidth to here, right? And we've also potentially shifted the distribution bandwidth to here, right? So, I mean, Aspera doesn't make clouds, but the fact that you can actually get the content across the network with speed, independent of that distance, starts to open this up. The fact that this isn't a two-step process means that this workflow can start going immediately, right? So all of these things start to build on each other. Netflix is a good example of this, right? So I'll tell you very specifically exactly what they do, right? At least at the the level that we see it. So Netflix's main innovation for using the Amazon cloud is their fleet of transcoding nodes, and they don't give exact numbers, but something like 1,000 plus Amazon EC2 instances are used on a regular basis to transcode Netflix incoming premium video content, right, into all the formats that go online. They have 100 plus providers around the world. They're of all sizes, everything from Sony and Deluxe and Technicolor to ad hoc independent studios spread around the world. Those entities upload directly using an Aspera client or a browser interface to Aspera server software, which runs on virtual machine instances, EC2 instances, and writes directly to S3. And that creates kind of a digital lake of content that sits there and is transcoded and then pushed out ultimately for distribution. This is about 100 terabytes on average a month, right? And each time Netflix goes to do a new international launch, like Michelle was talking about, the numbers spike up because they're preparing more content and getting it ready for a new international reach. Now, as I mentioned, this is a workflow that's been in place for the last 4 to 5 years, right, I would say. In 2008, when they entered the business, their first cut at this was to upload directly to Isilon clusters. So our server software ran on the Isilon clusters in their data center, and then they would do the job to get the content from Los Gatos and the South Bay up to the Amazon regions that they use, right? And that all transformed 3.5 years ago when we built the direct to S3 transfer capability. Now, some of the variations on this with 4K content, right? We are moving in 2 terabyte files. And what's interesting is because the object storage requires dividing those files into pieces, there are a few complexities that come into play, right? The I/O interface has to take care of writing all of those pieces in parallel to the storage, right? It has to manage the I/O layer while retransmitting any dropped data. It also has to manage the fact that there's a good amount of memory consumed in that I/O operation. If you're going to SAN or NAS storage, that isn't the case. And also concurrency, right, which is very easy against SAN and NAS storage to get very high transfer concurrency, also has to be fairly carefully managed against the cloud storage. Resume of files means that it's not as easy as just knowing you're going to pick up at a certain byte, right, in that 2 terabyte file. The objects are laid out non-sequentially in sort of across all the disks with a metastore that points at them. So if you implement resume, it has to use the logic of that metastore in order to know what blocks need to be replaced, for example, right? We're missing. So it's quite different than a linear transfer where you're writing directly out to storage. This use case I want to talk about because it illustrates the technology at play for a broadcaster that's dealing in both the traditional world with the OTT world concurrently. So this is one of our customers in the US, NBC actually, and they have about 58 different transfer endpoints around NBC and Universal and the parts of Comcast that support them. They deal in what you would think of as your sort of long-form, high-priority, broadcast quality content that gets transferred to London for playout, right? So more of a traditional broadcast model. And they also deal in sending directly to these OTT providers, right? What Michelle was talking about. And one of the points I want to illustrate or sort of bring out about the OTT providers is the volumes that go out to here are just as significant, maybe even more so, than the content that gets transferred directly to London to playout facilities. How do they do this, right? Well, all of it's based on the same type of infrastructure, right? So server hosts, Linux, Windows, etc., right? Running the transfer software as the foundation. A lot of times these are made HA in combination. There's proxy software that can sit in front. They choose to run it that way inside of the DMZ location, right? And those key DMZ locations, and remember NBC is now owned by Comcast, so they've got an integrated media operation, are in 3 places around the U.S. Inglewood Cliffs on the East Coast, Denver, and then Universal Studios down in Los Angeles. And at each one of those data centers, they run a combination of software that allows for ad hoc uploads. In this case, the Fastmix product, scheduled and automated transfers, right? Using interfaces as simple as watch folders as well as API integrations, for instance, with this product console for driving those transfers directly. And then they also support I would say a heterogeneous workflow where the ad hoc uploads into the browser interface result in relays, for example, from Universal onto Denver and also onto London for playout. And those relays allow them to achieve automation while also accommodating ad hoc transfer. There is the use of the orchestrator, which is a workflow automation suite. I want to pause on this a minute. After all this stuff, all these bytes start moving in both ad hoc and managed form, the next thing that comes into play is the desire to perform file-based workflow operations. QC, for example, transcoding, and to knit those together, right, in programmatic steps. And in this case, one of the examples of a workflow they built is the delivery directly to iTunes. iTunes requires certain packaging of the content, so they automate the packaging of the content with a orchestrator workflow. Prepares the metadata and then activates the iTunes transporter, which is a tool that Apple distributes that embeds our software for uploading to the Aspera servers at iTunes. Right? This kind of approach has allowed them to get a tremendous amount of scale as they move the digital media deliveries through the traditional as well as the OTT environments. And the next thing they're adding, recently interviewed them about this, is going directly out finished content for online streaming out to Akamai using the same approach. Right? Because the infrastructure is common, right, and they have relatively good bandwidth between locations, and both ad hoc and managed abilities, they can keep expanding this footprint. This whole thing has grown in the last year and a half, right? So it hasn't been very long, and it kind of speaks to the leverage that you can get off of approaches like this. They do not yet use any cloud deployments in this particular ecosystem, but that is a common expansion point for some of the other broadcasters and studios. Okay, I have another use case I want to share. It's quite different, very interesting, coming out of the UK, focused on sports. This company, Perform Media Group, has used Aspera transfer software for a while, but they came with a sort of another level of problem, right? And in this case, their issue was really the automation of how they prepare all of the live event content that goes online, right? So they have huge volumes of it. It needs to be turned around very rapidly. And the products that they make, right, are all about reaching the consumer with this sort of near live experience. And you can see some of the statistics here. So what they've ended up doing is building a fully automated platform around Orchestrator, where they reduce both the footprint and the staff way down, right, to almost entirely cloud-based scale out, and they quote themselves, there's one administrator that really runs this entire solution. I don't know if that's accurate, but that seems to be the way they feel the solution has taken them, right? So let me tell you a little bit about how this goes. In the default case, content gets ingested, uploaded as a file to an on-premise Aspera server. The orchestrator, which is this file-based workflow automation software, manages the content and prioritizes where it goes in the queue, and then it allows for executing multiple parallel transcoding jobs. And when that transcoding queue monitored by orchestrator reaches a certain watermark or threshold, it scales out, right, to use transcoding up on Amazon. So automatically the content is shifted, right, basically uploaded directly to Amazon, transcoded there, and then distributed directly out to Amazon. So they have two parallel distribution architectures, one on Amazon, one on premise. And the orchestrator is the brain, if you will, that allows for setting the criteria for migrating the workflow. The orchestrator doesn't have bespoke workflows. These are all also programmatic, right? You leverage this file-based approach. And they go another step where the clips themselves are actually captured automatically and prepared by orchestrators. So in this case, there's an incoming data feed from the matches that's processed in real time by orchestrator. The key moments are identified. The orchestrator creates new clips from that and then sends these clips to the existing workflows automatically. And each one of these is processing those clips in parallel. I don't know if you saw the volumes of media that they deal with, but if we just step back here, right, looks like they're dealing in 65,000 live events that are fast scored. So the volume of this is quite significant. The time they took to make this transformation, right, was basically 6 to 9 months. Right? And again, the reason I want to include them is because by laying the groundwork, right, with this sort of, if not only file-based, but if you will, sort of programmatic, platform-based approach, they were, able to leverage this very quickly and to a very high degree. Okay, I have two more cases I want to share with you. This case is from Scripps Networks, who also made it into the Michelle's talk as well. Scripps is a big embracer of cloud technology, and they came to us recently with a use case that kind of surprised us. We said, why are you doing this? And they said, well, we do not want to deal with the spikes in ingest bandwidth that are needed for the variable, content load that we have incoming to the network. Sometimes it's very big, sometimes it's very small. So they put together an ingest workflow, uses the Aspera Fastbook software to upload directly to Amazon S3, but before the files are made available in S3 for pulling back down to Scripps, right? So they just go up and come back down, right? Allowing for this ingest load to grow and shrink, because you can get more nodes on Amazon and more bandwidth it will. Before they let the content come down, they have an orchestrator workflow that validates the files. And the validation is done for QC and conformance check. And some of this is very simple, done with media info, and some of it is more advanced. Also virus scanning. I mean, very simple, but typical for people. And interestingly enough, their sole reason for going through the cloud environment in this case was to avoid having to get enough internet bandwidth to over-provision for the times when they have, high loads, for example. And then I picked out one more case, and this is actually the big guy, right? The biggest cable provider in the world. They, as Michelle so aptly described in the previous talk, are definitely positioning themselves for this digital world, right? And one of the big changes that we've seen through an architecture we're involved in has to do with changing out how VOD content gets to the headings, right? So obviously positioning of advertising is the strategic thing you can do. The first order thing to do is get rid of the limitations and cost of satellite multicast. So what they did was put in a new system where this used to be a satellite multicast, right, to all these regional head-ends of the VOD content. put in a new system that uses our Fastbix application software to essentially have all of the head-ends running a lightweight client, Aspera client that subscribes into a push channel and downloads the VOD content, right? You look at that and say, well, that's remarkably simple. Well, the volumes are really big. The files have to end up at each of these head-ends on time, right? They have to go very fast, right? And it has to work every time. And it has to be automatable from their content management system up behind. So the Fastbix application software happens to work very nicely for this. And to Michelle's talk, what they're able to do is exploit all their terrestrial internet, which already exists, the fact that the VOD content's in file form, and have a simple content routing by virtue of the work groups in Fastbix, where the cargo clients that are on each one of these head-ends are subscribed, and the content published to their groups is what they download. Right? So this has become their mechanism for distributing the VOD content to the head-ends. It ties in to their existing content management system through the Fastbix APIs. So instead of a user going into a browser interface to upload, they just publish directly in through an API call, right? So the files are actually back here in this big NAS system. They get uploaded through an API call, right, to the Aspera server software that is the Fastbix cluster, and then all of these head-ends are subscribed and download the content. The cost change of this, if I'm not mistaken, is a fraction of their yearly cost in the first year, right? So to buy the whole thing. So imagine you make a capital purchase of software that's a fraction of your yearly cost. Right? So it is utterly transformational in terms of the cost. And I think with the bigger point to Michelle's previous talk here is the fact that they are positioned now such that all of this is digital